in this session, it's functions number 2. We're going to now start focusing on the parabola. And like I said in the previous one, we're going to take it step by step. We're going to move it. We're going to move it up. We're going to move it sideways. We're going to move it left. We're going to move it right. And then we're going to cover some of the examples that we have, that you will see. A lot of the examples I'm doing, I haven't chosen ones that end in very nice numbers. I've chosen things that end in root 7s and things like that. Okay, so just to make sure, not all of them, just 1 or 2 of them. Okay, let's have a start with the parabola, shall we? In the parabola, what have we got? We know it's either that way or it's that way, and it's a general term. Okay, let's just put a heading, parabola. Okay, now in the parabola, we had that. We've got a new standard form. A new standard form. Y equals ax squared plus bx plus c. And if you remember, that was the quadratic equation. Is it not? All right. And if you remember, okay, how did we factorize quadratics? We actually ended up with the 2 brackets scenario, didn't we? Okay. Now, there's a standard form over here. Another standard form is y is equal to a times x minus r1, x minus r2, where r1 and r2 are the roots. They would have been these 2 guys here, correct? They would have been those when we solved it. Remember, 3 and a 2, a minus 3 and a plus 5, whatever the case might be. That's the 2 numbers that fit into those brackets. And then the last one, or we've also got another one, y equals a, and it's x minus p all squared plus q. And this was the turning point. Okay. Now, you might as well already say, you know what, get used to it, because what you're going to have to do is you're going to have to learn all 3, okay? Because when we get to not sketching them per se, but when we get to the questions where they say find the equation of, you're going to look at all 3 and say, what have they given me? Either they've given it to me in root form, or they've given it to me in turning point form, or they've given me the generic, okay? Now, let's just have a look at this, okay? The turning point, remember, it came from completing the square, and we've got, it must be, let's have a look. Let's pick let's say we have this, all right? A situation. Y is equal to x plus 3, 2 times x plus 3 all squared minus 4. Let's say this is what we are given. All right? We are given. And for argument's sake, they want us to sketch graphs. Please look. The standard form is this. A x minus p all squared plus q, right? Q, okay, remember p and q are the x and, let me write it underneath, okay, are the x and the y of the turning point of a parabola, turning point. But it's in the form minus there, but we've got a plus. So we have to do some manipulation, right? What do? We just rewrite it in terms of this, and we say it's 2x minus 3 all squared plus, my bad, I'm thinking of the standard form here. Okay. Minus 4. Therefore, P equals minus 3 and Q equals minus 4. So the turning point is minus 3, minus 4. Right? So when we're given it, always remember you may need to do some of that manipulation, all right, to make sure you get your sign correct. Okay? Don't skip it. Just have a look and say, it's in a plus, so I'm going to change it. We're going to see the same thing in a hyperbola soon as well. All right. So let us say they've given an example. All right. Let's go through an example of sketching a graph. And you know the rules already. Sketch a graph of, or sketch the graph of, let me just put the over there. Sketch the graph of f of x, I've put it in function form, is equal to 1/8 x plus 2 all squared minus 2. Can you see they haven't told us it's in the turning point form, but you look at the function given. Decide which form. Form is turning point, root, or let's say generic. Okay, I'm going to go and label those at the top here. Okay, we've got turning point, root form there, and I'm just going to call this the generic. In other words, they haven't given us turning point. All they've given in that one is the y-intercept essentially, hey? Because C is there. Okay, let's look. This is in the turning point form. Therefore, let's have a look. We say, okay, step 1, shape. A equals 1/8. Therefore, it is a happy face. It's A is greater than 0. It's positive. But this you can do if you wish. But it's going to be flat because A is a fraction. Okay? All relative to 1x squared. That's the shape. Number 2, we say, okay, turning point, let's see. Well, no, let's just first of all say, okay, let x equal 0. Okay, and you put x equal to 0. F of 0, notice I'm just doing this way for a change, is equal to y is equal to 1/8 of 0. Just go back. Okay, it's 0 plus 2, correct? All squared minus 2, which is 1/8 of 4 minus 2, and my answer comes out to be minus 3/2. Okay, so now we've got the coordinate there. That coordinate, remember, we always write them down. 0 minus 3/2. We write them down so that we don't make a mistake later, which is very common, okay, to do. All right? So question 3, or step 3, sorry. Put y, let y equal 0. Therefore, 0 is going to be equal to 1/8 of x plus 2 all squared minus 2. Okay, take the 2 to the other side, multiply by 8. You get x plus 2 all squared is equal to 16. No, you don't have to multiply out, take across and factorize. Remember, in completing the square, you can just take the square root of that side straight away. So we can say x plus 2 is plus minus 4. Therefore, x is going to equal to minus 2 plus or minus 4. Therefore, we've got x1 equal to, it's going to be minus 2 plus 4, okay, which is that, and x2 is going to be minus 2 minus 4, which is minus 6, and that is going to be plus 2. So therefore, I've got 2 more points over here. I can say it's going to be 2 and 0 and minus 6 and 0. Okay, these are straightforward, aren't they? All right. And then I say, right, last of all is my turning point. Okay, turning point. This would be step number 4 of the recipe. Okay, step number 4 is the turning point, and it's given in this case as minus 2 minus 2. Right? P and Q. P after we did that rearrangement. Remember, it was a plus, which means P is actually a minus. It is shifted to the left. Okay? I'm not going to make a thing about just a jump to the... Never mind. Okay. Let's move along. Now then we say, okay, let us sketch said graph. We do a thing like this, and we put minus, okay, 1, 2, 1, 2, turning point there, okay, 0 and 1.5, okay, there, and we had 2 and 0, 2 and 0, and over here we had minus 6, 2, 4, 5, 6, and we had a graph that does this, okay, something like that. That's not the greatest. Let me just try and tidy that up a little bit. It's because it's not. Okay. And you would label origin X, Y. This point here is minus 2 and minus 2. And this point over here you'd label as the intercept 0 and minus 3 over 2. All right. These are all our points, and this is 2 and 0. And this is minus 6 and 0. And there's our turning point. Okay. And it has a minimum of minus 2. Right. The domains and the range, etc. Okay. Very, very straightforward. Okay. Have a look. Sketch the graph. Okay. Example. Okay. Sketch the graph of g of x equal to minus 2 x minus 4 all squared plus 16. All right. Sketch that graph. G of x. Usually you get asked f of x or g of x or h of x. Okay. They all mean the same thing. Okay. There's no difference. It's a different function of x though. Right. All right. So first of all, we go shape. Right. Step 1 is our shape. What do? We look at A. A is going to be less than 0. It's minus 2. Therefore, it's a upside down sad face. And if you really want to, it's slightly tighter. Slightly tighter on the axis, right? I wouldn't really make a big deal about that because we're going to plot it anyway, so it's not really an issue. Shape. Section number 2. Well, let's let x equal 0. Okay, number 2. Let x equal 0. What do we do now? Okay, we put y equals minus 2 times 0 minus 4 squared plus 16. This is where most of the mistakes creep in, just by the way. That is 16. Okay, plus 16. The answer is minus 16. Put down your coordinates, 0 minus 16. Next step, step 3. Let y equal 0. Same thing every single time. And let us say, leave your answers in surd form. Let us say they have said at the top here in part of the equation, and leave answers in surd form. That means don't simplify roots, doesn't it? So we now say 0 is going to be equal to minus 2 times x minus 4 all squared plus 16. Take the 16 over, becomes minus 16 minus 2, x minus 4 all squared. Divide by minus 2, I get 8 is equal to x minus 4 all squared. Take the square root, so therefore plus minus root 8 is equal to x minus 4. Therefore, x is going to equal to 4 plus or minus root 8. All right. Now, in surd form means we need to simplify the surd. Anybody remember how to do that? It's root 8. Well, that is equal to root 4 times 2. Now I can take that out to 2 root 2 because the square root of that, or if we want to be purists, okay, come on, let's be purists for a while. This is going to be equal to square root of 2 squared times 2. I can now take the square root of that, which is 2 root 2. There we go. We've got purist in our midst. All right. So therefore, the answer is going to be 4 plus root 8, 0, and 4 minus root 8 and 0, because y was 0. Those are our 2 points there, correct? Let me rephrase it and put it in terms of plus 2, plus 2 root 2 minus 2 root 2. For those of you with the calculators, that's what you're going to see, aren't you? You're going to see 2 root 2s, 3 root 2s, 2 root 3s, etc., etc. Now, let's see what remains now. What haven't we got yet? We haven't done the turning point. Because we need 3 points to plot it, don't we? Sketch it. The roots, that's 2. And we need the turning point. 4. I was thinking the roots. We need 4 points. The 2 roots, the turning point, and the y-intercept. The turning point was, let's have a look. It was x minus 4. Okay, just go back to my graph. It was y equals minus 2 times x minus 4 all squared plus 16 p q. And it's in the standard form. Mine is a x minus p all squared plus q. Therefore, it's in the standard form. Therefore, turning point is going to be equal to 4 and 16. And we can go ahead and we can draw the graph of this now, can't we? We can draw the graph. Let's say, all right, there we go. I'm just going to draw it slightly like this. All right. And we say that's going to be, it's just over 1. It's going to be there. And it's actually 1.18, or this is 2 plus 2 root 2. This one over there is going to, I just decimalized it just to be able to do it, is 6.83 and 0. And this is 1.18 and 0. Over there, y-intercept at minus 16. And the top here was at 4 and 16. So we had something that looked like this coming through there, like that. 4, 16 was our turning point, and we got our roots, and it's got a maximum value of 16 plus 16 in this case. All in all, not really a difficult task at all. Let's do another one, okay? Now they say to us, let's look at a simple one. Y is equal to this. Another example. Okay. Y is equal to this. X minus 3 all squared minus 4. Well, first of all, shape, right? Shape, A is equal to 1. Therefore, A is greater than 0. Therefore, it's happy face. 2, let x equal 0, right? If I let x equal 0, I get y equals minus 3 all squared minus 4, which is going to be equal to 9 minus 4, which is 5. Okay. So we've got that. So my point is 0 and 5. Right. Next question is let y equals 0. All right, and if we put y equals 0, you get 0 is equal to x minus 3 all squared minus 4. That becomes 4 is equal to x minus 3 all squared, which becomes x minus 3 is equal to plus or minus 2. Okay, therefore, x is going to be equal to 3 plus or minus 2. So I have got two coordinates here. I have got 3 plus 2, 0, and 3 minus 2, 0. And obviously you don't leave it. That is 5, 0, and equal to 1 and 0. Like so. Okay. And the last thing that I do is I say, okay, turning point for turning point. What do we say? Turning point, it's given to us, basically. It's in the formula, and we write down the standard, and we get that our turning point is 3 and minus 4. The last thing we do is we go and we plot it. All right. Draw that axis a little bit off that way. And we say, righty-ho, you are at 3 and minus 4. So you are there, 3 and minus 4. I put my roots in at 1 and 5. And we put this in at 5. All right, and we go down and turn and go up. And it's got a minimum value equal to minus 4. Okay. I hope the last one I said a minimum instead of a maximum, or maximum instead of a minimum. And there she is. And you label your points here are 5 and 0. That looks like 52 and 0, doesn't it? It's 5 and 0. And that point there is going to be 1 and 0. Okay. So it's a parabola with a minimum value of minus 4. Now, let's just look at this parabola, shall we? Please note that on a parabola, okay, let's just do a little bit of understanding, okay? A parabola has got that, look at the axis of symmetry of a parabola. I'm just going to redraw this guy. Whoops, that's, okay, somehow I should get a template for this, hey? Okay, let's redraw you. Put you down and try and be a little more precise, okay? Let me just draw this at 1, 2, 3, 4, 5, okay, and 1. So there's my two roots, and I said it's 3 and 1, 2, 3, 4. There was my turning point, right? 3 and minus 4, all right, and 5. 1, 2, 3, 4, 5. So our parabola is coming down here through there, turning over here, and going up over there. Okay, not beautiful, but what the heck? Let's just stay with it. I want you to look at the axis of symmetry. Okay, in other words, it's the axis of symmetry is at x equals 3, is it not? If I fold it about that point, remember, I get the graph folds over itself, doesn't it? Now, let's just look at the roots. I know this, people might say, yeah, but I mean, that's obvious. This is 5 and 0, and this root here was 1 and 0. The distance from there to there is going to be equal to 3 is 2. The distance from there to there is also 2. So please remember, if you know one root plus the turning point, you can find the other root by scaling it. If I gave you that and that, and I said, what's the root? You'd say, well, it's 2 to the axis of symmetry, and then you would subtract 2 from this guy, wouldn't you? Minus 2. you'd say, I'm going backwards, there's 2, so I must go backwards another 2, right? That's what you do with these. The axes of symmetry, in essence, are going to be very useful in this and a parabola. So what is critical here is to know that the axis of symmetry and turning point, okay, those points are critical because we're going to be moving the graph to the left and the right. Just before we move on to the next section, can you see this graph, put it onto green, is actually the old parabola moved, okay, 4 down and 3 to the right. Okay, it's moved 4 down and 3 to the right. Okay, what am I'm saying the parabola that was over there? Okay, my reference parabola is that guy there. I have moved it that way and down, right? So we move, when we look, we move the turning points, okay? Right. The next section I'm going to carry on with parabolas, axes of symmetry, moving them. Then we're going to solve a few of the parabolas. We're going to find the turning points, not the turning points. We're going to move them and then find the equations of them. Please go back and have a look at that sketching. You have to remember so little. It's worth quite a bunch of marks, and it's really, seriously, it's not that difficult if you go and look at it, is it? Cheers. Have a great one. Bye.